In section 1.5, we're going to be solving equations and inequalities by graphing. Desmos will be one of your main tools for this. Eventually, we'll be solving them algebraically, but today, Desmos will do a lot of the work for us. Let's start with example 1 in your packet. How can you use a graph to solve an equation? They say to solve this by graphing. I'm going to flip to the next page. We could graph it by hand. And I encourage you to think about, this would be a line, negative 3x plus 20, and another flat line, 5. Graph both of those and figure out where they're equal. What x value will they be meeting at? So I've done that here on my Desmos. You can see my negative 3x plus 20 graph is the light blue, and the purple is the 5. I've clicked where they meet. If you just click on that in Desmos, it will actually plot a point for you. And there I have 5, 5. So our example 1 answer would be that they would meet at x equals 5. For part B, they say to graph this again. Now, if you were thinking about this and wanted to graph it by hand, remember the absolute value of x when you dealt with the parent function? You should remember what that minus 4 does. Remember that moves it to the right 4? So you'd basically have an absolute value graph that kind of looks like that. And then this guy would be a slope of 1/2 and start at 1, your y-intercept. We could graph those by hand, and I bet you could. I'm going to go ahead and look at a Desmos version of it. And I see my red absolute value graph and my blue line. This time they have 2 places or 2 x values when they have the same y value. So our solutions for this part B on example 1 are when x equals 2, because if we come back to this graph, we can see when x is 2 here, and when x is 10. So we would write both of these answers. Pretty simple in terms of the answers, especially when you use Desmos and you can click on that intersecting point. These try-its, for example 1, you'd want to try on your own. Your answer can be found on your teacher's Canvas page in PDF form. So try these 2 and see if your answers are correct by checking the answer key. All right, we move on to example 2. How could we use a graph to solve an inequality? Remember, an inequality is one of those alligators or gator signs, if some of us might call them. You might even have an equals to underneath, okay? So let's look at this one. They give us a parabola, x squared minus 4. Hey, think about your transformation. That's that parent graph, x squared, shifted down 4. So they graphed it here for us, x squared minus 4, and they want to know when is it greater than 0. Now, this is like the equation y equals 0. That's that flat line all the way across. It's basically the x-axis. When is it greater than 0? Well, if I take my highlighter here, I can see it's greater than 0 right here and greater than 0 right here. Kind of reminds me of when we answered when is a function positive. They're just now using some inequality notation. So we're going to say it is greater than 0 before negative 2. So I'm going to use interval notation. From negative infinity up to negative 2 and from 2 to infinity. Now, back when we answered when something was positive or negative, we always used the parentheses, especially with infinities, but also with these values, because at negative 2, the y value is 0. It wasn't positive or negative. Now we use the parentheses because of our alligator or our inequality. There's no equal to down here. So we don't want it to equal 0 or be 0. We want it to be above where the orange is. That's why we say it only goes till just above negative 2 or before negative 2, and then, of course, from 2 and on. And we can see that there on that Desmos as well. Again, there's our graph. You could always check on there, but we're just looking for when it's above the x-axis. And those x values here, these are all these x values in an interval notation that would give us that equation being above 0. For example, to part B, we have to do a little bit of thinking and maybe equation creation. We have a motorcycle 40 miles ahead of a car, gets a head start. He travels 40 miles per hour. The car goes 60 miles an hour, so it's going faster, but it doesn't get a head start. Where will they when will the car be ahead of the motorcycle? I also like to think of, gosh, when will they meet up? When will he catch up? So let's think about our equations. If x would represent time, so in this case hours, and our y would represent distance or miles, we could see if we could create an equation. So for every hour, like think about the motorcycle, it's going to go 40 miles per hour. 40 miles in 1 hour. If x is time, if we think of x as being time, when he goes 1 hour, he's going 40 miles. If he's traveled for 2 hours, he'll have gone 80 miles. So if you think about that, every hour he travels, he'll go another 40 miles. Kind of like that multiplying relationship. So when it comes to the motorcycle, I would say he's going to go 40 times x. He's going to travel 40 miles each hour. Now, as for the car, he's going to go 60 miles every hour. So again, if he traveled 3 hours, we could put that 3 in there and go, oh yeah, 60 miles, 60 miles, 60 miles. He's going to go a total of 180 miles in 3 hours. So that's why I like these equations. Now, they're both not starting at the same point, so we need to take into account that he's going to go 40 miles every hour, the motorcyclist will, but he already gets a head start 40 miles ahead. These are the two equations that they're hoping you'll come up with, and you can graph those now to find out not only when they meet, but when will this car get ahead. I went ahead and graphed both of those equations on Desmos. And here I see, I had to make a scale a little bit to zoom out for you here. Here I see this coordinate where they're meeting when x is 2. That means, remember, x was hours. So let's think about it. That means in 2 hours, they'll both have gone a distance of 120 miles. Now after that, though, here is our 0, 0 starter. This is our car in the black. He has traveled. He will now take over. So I found when they're equal. Right here is when they meet. Now I want to know when the car has gone farther than the motorcycle. That is right here on the graph. So I'm going to make my cutoff like I did with our domains back in the day from here to here. Now if they drive forever, assuming they don't run out of gas, that car will always be ahead from now on. But we're going to answer in our interval notation that the car will be ahead of the motorcycle when x is greater than 2. So after 2 hours, they'll meet and the car will now be ahead of it. Notice how it says only ahead. It doesn't say when will it meet it, so I'm not going to use the equals to sign. X is greater than 2, or after 2 hours, the car will be ahead. Finally, there is the try it. You could do this. Again, I recommend Desmos. You can graph your parabola here and see when it's greater than 0. For this guy, you're going to have a line and another line. They're going to ask, when is this line greater than this line? Kind of like those motorcycles. Notice how when it was greater, when the car was greater distance than the motorcycle, that's when this line was above, when the car was above the motorcycle. So be thinking of that. You'll want this line to be above this line. Again, check your answer key for the solutions to this triad on example 2. The final example 3, we now have a parabola graphed in red for us and a line graphed in blue. They want to know, when are they equal? They do talk about using the tables. You could look at some values, but for right now, since we're not solving it algebraically, let's go ahead and just zoom in on Desmos, and if we made a click right there, we would find that, well, it's crossing like between 0 and 1, but gross, it's like a decimal. Same thing here. I can't really tell from this graph, so that's where I'm going to recommend you go to Desmos, graph your parabola, graph your line, and click on the points where they meet. For this problem, we would say they meet when x is 0.697, so we can write that. And when x is, again, they meet here when x is 4.0 303. Again, Desmos will be your helper on these. You'll want to click on it. We will talk later how you could use the quadratic formula, but they do cross twice, so be aware of that. There's a try it for you to try. Same idea. Just graph it and look across the whole graph to make sure you see if they meet twice.